Think and solve 17.34. Part A. Determine the number of calories to change 1 kilogram of 0 degrees Celsius ice to 0 degrees Celsius ice water. Here's a graph of temperature versus time. This line is showing that process. It starts off with ice at 0 degrees Celsius and ends up with ice water at 0 degrees Celsius. Okay, so I guess I'm going to apply Q equals ml subscript F. So number 2 is Q equals the mass of the ice, which is 1.0 kilograms, times the latent heat of fusion, which is given as 80 calories per gram. I'm going to convert from kilograms to grams by multiplying by 1, and here's how I'm going to write the number 1. Now I can cancel kilograms here with kilograms here, grams here with grams here, and I'm left with calories. So I'm going to convert from calories to kilocalories by multiplying by 1. Here's how I'm going to write the number 1. If I write the number 1 this way, calories here cancels with calories here, and I'm left with 80 kilocalories. The takeaway for this problem is I need to add 80,000 calories to 1 kilogram of water to convert it from ice to ice water. Notice the temperature isn't increasing. All this heat I'm added is simply breaking the bonds and changing from solid to liquid, which is called fusion. Part B is saying, okay, you've melted your ice. It's now ice water. Add some more heat to turn that ice water into boiling water. On the graph, it looks like this. Here's my ice water at 0 degrees Celsius. I add some heat and I'm ending up here with boiling water at 100 degrees Celsius. I'm not phase changing, I'm just changing temperature, so I'm going to use Q equals mc delta T, my specific heat capacity equation. So step 2, Q equals mass, which is 1.0 kilograms, times the specific heat of water, which is 1 calorie per gram Celsius degree, times delta T, which is my final temperature, 100 degrees Celsius, minus my initial temperature, which is 0 degrees Celsius. Delta T means final temperature minus initial temperature. This is my final temperature. My water heats up to 100 degrees Celsius. This is my initial temperature. I started out with a chunk of ice that melted and was sitting there at 0 degrees Celsius. I have to do some conversion, so here goes. I have Q equals 1.0 kilograms, which I'll convert. Here's my number 1. 1,000 grams in the numerator is the same as 1 kilogram in the denominator, so that's my number 1. Here's the 1 calorie per gram Celsius degree. I'm going to convert that by multiplying by the number 1, and here goes. 1 kilocalorie in the numerator is exactly the same as 1,000 calories in the denominator, so that is the number 1. 100 minus 0 equals 100, and now I'm going to write Celsius degrees. Celsius degrees is how I write a temperature difference. Degrees Celsius is how I write a specific temperature value. Time to cancel. Kilograms here cancels with kilograms there. Grams in that numerator cancels with grams in that denominator. Calories in that numerator cancels with calories in that denominator. I'm left with kilocalories because this Celsius degree cancels with that Celsius degree. So the amount of heat I need to add to this ice water sitting there in liquid form at 0 degrees Celsius is going to equal 1.0 times 1,000 times 100. All of that over 1,000, and you can see 1,000 there in my numerator cancels with this 1,000 in the denominator. My units are kilocalories. I went through that, and that means my answer is 100 kilocalories of heat needs to be added to liquid water at 0 degrees Celsius to warm it up, not to phase change it, but to warm it up to 100 degrees Celsius, which is the boiling point. Part C, now I need to take that boiling water and keep adding heat and convert all of it into steam at 100 degrees Celsius. Here's what it looks like on the graph. I'm here with water boiling at 100 degrees Celsius. I continue to add heat. My liquid water keeps converting into steam, which is why I'm flatlining. All of that heat energy is going toward converting from liquid to steam. And finally, I get to this point where I have all of my water now converted into steam. That process is called vaporization. From gas to liquid or from liquid to gas, as we have here, that is called vaporization. So this is a job for Q equals M times L subscript V for vaporization. So number 2 says Q equals the mass, which remains at 1.0 kilograms. I started off at solid, went to liquid, now I'm at gas, it's still 1 kilogram, times L subscript V, which is the latent heat of vaporization, and that number is 540 calories per gram. So now I have some conversions. I'm going to multiply by the number 1 like this. There are 1,000 grams per kilogram, so that's the number 1. Then I'm going to multiply by the number 1 again. In this case, it's going to be kilocalories in the numerator, and that is equal to 1,000 calories in the denominator. And I can go through and cancel. Kilograms here cancels with kilograms here, grams there, calories there, and I end up with my answer. The amount of heat it takes to convert water at 100 degrees Celsius into steam at 100 degrees Celsius equals 1 times 540 times 1,000 divided by 1,000, and my units that are left behind are kilocalories. It takes 540 kilocalories of heat to convert 1 kilogram of boiling water into 1 kilogram of steam. That process is called vaporization. From liquid to gas or from gas to liquid, that's referred to as vaporization. Part D wants you to add everything up. You need to find out how much total heat is needed to convert 1 kilogram of 0 degrees Celsius ice to 1 kilogram of 100 degrees Celsius steam. This was the answer to part A. 80 kilocalories of heat was needed to convert from solid to liquid, that's called fusion, and then I needed to keep adding some heat to warm up that melted ice water to the boiling point, and that number was 100 kilocalories. And last but not least, I had to invest another 540 kilocalories of heat to convert all of that water at the boiling point to steam. Converting from liquid to steam is called vaporization. This is why you see a flat line again. All of that heat added doesn't raise the temperature, it's just changing the phase. So you just take your answer from part A plus part B plus part C. Part A plus part B plus part C, and that's the total answer.